So my name is Andy Schneider. I'm Field CISO Mayor of Lacework. Lacework is a cloud security company. And it's always difficult to talk if you are the one between you and your lunch. So who's hungry? You're hungry? Okay, that's good. Who's tired? It's okay, you can be tired. So because I got a question, so with the app you can ask questions. What is the one thing that can go wrong in your cloud migration? It's all about leadership in a company. And the worst thing that you can do is make difficult decisions when you are hungry or when you are tired. So my advice, the first thing, do that when you are not hungry and not tired. So I will not overextend the session so that you can have a good lunch. But maybe you can help me going through that session. So what is it if you go to the cloud? It's, oh, by the way, question, who's already in the cloud? A lot of people, that's great. So some not. So I always call it the clash of beliefs. So if you go to the cloud, there are suddenly things that are different. You have the developers are somehow different than they were before. You have new methodologies there, and it's really a clash of beliefs, especially for us as security people, if we come from an on-prem world and then encounter the cloud. The journey started for me around 10 years ago. I've been a CISO, and I never understood why developers don't follow my policies. I got it, took some years to get there, and I will guide you a little bit through that journey. One main thing that happens is that security, by the way, does anybody know that? What this is? Looks familiar? That's the Rainbow series. So security, how we do that today, comes from the military. And that's a good thing. In the military, that works quite well. So there's that famous Orange book. That was one of the first ones I had to read. And if we think about security, these are controls. So the language that we use in security is not like an enabling positive language. Everything that we use is more military style, hierarchical. And that's the first clash of beliefs. The military is hierarchical, and that's good for the military. If you go to a pure cloud environment with DevOps, you find less hierarchies. So applying controls just from a language perspective is already difficult. So the first thing that I advise everyone is thinking about, could we just give it another name, like security stories? That's still a control. You can call it, translate it from a control to a security story, but it will be way more appealing to your developers. It's like another question, do you have kids? Anybody? So if you apply the latest control framework to your kids, they will love you. So there are other ways of doing that. You achieve the same goal. Even if it's a control, it's different. So think about changing the language that you use, even if you do exactly the same. It will be more appealing to your developers. So out of that hierarchy, also you have that typical way of implementing security. So you have the security strategy, you have the CISO on top, and you have the controls, and you have the people down there. That is, again, a concept that works in hierarchical organizations. It doesn't work well in flat organizations. So if you encounter a flat organization where the individuals take over more responsibilities, you typically have that in DevOps. That is not really working well. You can try that, but it will be a daily fight. So what I'm saying is, it worked. I did that in the past. You can still do that. But everything around Agile and DevOps, they are independent to cloud, but they are like a super good couple. So they work together perfectly. So Agile, DevOps, the cloud, and new work. So people want to work at home, even if we have that little bit of feedback loop now that people want to have everyone back in the office. But the way we work has changed. The Gen Z is different, so you have to, as a leader, you have to see that people have other demands, and actually the cloud is there, and that eats up security. So I remember one story, it was 6 years ago. I had a development team digitizing the broadcast business, around 40 developers, and I had a tiny security team, 5 people, and they were not following my controls. And then I had a discussion with a platform, a head of platform, and he said, listen, Andy, do you really think that just in case we get fired, we digitize the business and you just block us? Just think about that. And I thought, well, yeah, maybe we won't fire all our developers that develop the new ground rules of the future, and I'm the blocker for them. So actually it was true. So I had to find ways to influence them. So what I learned from them is that in security we say the cloud is just someone else's computer. And that's not true. It is true from a technical perspective. The host is hosted by AWS, Microsoft, or someone else, but the cloud is much, much more. Because if you are in the cloud, you can look what they are doing. Do they really log in to the server in the cloud and do patching in the cloud? No one is doing that anymore. The way you maintain cloud is totally different to the way that we did that in the past. So everything is code. That's a beauty that you have to learn. So in the past, the security engineer didn't have to be able to write code. Today's security engineer, in my opinion, need to be able to write code. That's just an essential skill to understand, because everything is code. And that's a good thing, because if everything is code, you can more or less, you can formalize security. Everything can be a pull request. The 4I principle is much easier to apply on code than it was in the past. So change management, all of that, that's formalized, fully automated, and working way better. And that was almost impossible doing that on-prem in the past. So as we do that, everything is code. You can do security as code. That's perfect. So if you do security as code, you can do that continuously. You don't have to recheck things, so you can do that continuously. So you run the code throughout your CI/CD pipeline, it ends up in production. And the C means continuously. Who's still doing pen tests? It's not a bad thing. Pen tests are a good thing. No, not a question. Pen tests are good. If you get the result, do your developers like the pen test, the results? Usually not. Most people hate it. You get like a huge report, either an Excel sheet, PDF, 2,000 findings in there. You do that regularly because you do that continuously, so you do that weekly, maybe monthly. And developers just don't do anything with that, because that's not continuously. Continuously means you do that every hour, every minute, every time of a deployment. So we still have to find a way to find vulnerabilities. But the way in the cloud can be much different to find vulnerabilities. I'll come to that later. So doing things continuously. For everything that you apply in security, think about, can I apply that in an engineering way and continuously? That's the big challenge. Is there a way that I can automate what I'm trying to do, like automating my audit, the pen test, the whatever you do, the checks, so that you don't have to do that manually? Then, if you talk to developers and tell them, we can automate that, they will have a lunch with you and they will tell you how they will be able to automate that for you. They will love that. It's again a language thing. So, like I said, automation is key. Then there's that beauty of the cloud. You can scale. So I remember the first time I used a SIEM from a large vendor that I won't name, that almost everyone used in the past. So we used that, and I thought, why don't we look at behavior-based patterns? So what I did was machine learning. But the problem with machine learning in an on-prem environment is that machine learning needs a lot of resources. And we had limited resources. I couldn't just say to our IT, we need just 1,000 computers for the next 30 minutes, and then I don't need them anymore. That's not working. So scaling up is a problem if you're on-prem. The same for scaling down. That's just not working. But in the cloud, if you need the resources, you can just scale up almost unlimitedly. It costs you money, but only for the time you need it. Then you can again scale down. This makes machine learning possible. That's why we have now a lot of AI out there, because that scalability is there. You can do that on-prem as well. You just need a lot of money to buy that machines that you need. It's just CPU power and GPU power. That's all you need. So, but scalability is the one thing that brings the cloud to us. So scalability helps us doing machine learning, but other things as well. Now, if you plan to move to the cloud, there is the one and only advice from me: don't lift and shift, because then you don't benefit from the cloud. If you lift and shift your workload, so your virtual machine, to the cloud, it's not scalable in the cloud. Then you have, so if there's someone from the hyperscalers here, if you operate the same server in the cloud, it will be just more expensive, full stop. The cloud is not cheaper, but you have other things like the scalability. So rebuild things cloud native. You can do that serverless, on Kubernetes, whatever, but think about scalability. How can it benefit from that, new technologies that are out there? And do things as code. Either if you have infrastructure, do everything with Terraform, CloudFormation, whatever you use. But don't do things manually. If you do that, jump into the water and sink as low as you can, because that's a sin. Never do things manually. Do everything as code. Because this also means if you do security remediation, you do that as code. You don't do that like blocking things somewhere and killing things like you did that, for example, with an EDR. You just don't do that that way in the cloud. You can fix the problem in code and redeploy. That's a playbook that every developer understands and can deploy. So rebuild cloud native, do everything as code. So what does it mean for security? By the way, it's a PDF. This should be animated. So I should look around. Didn't work. So if you are moving, if your IT or technology department is moving to the cloud and you end up being part of that transformation, don't lift and shift your security. That's the same sin. If you think, hey, we have our IDS, we have our IPS, we have our firewalls, our proxies, we just do the same architecture in the cloud, it will work, but you don't benefit from the cloud. It's like that scalability problem. So don't lift and shift your security. You still need to achieve the same goal, like finding vulnerabilities, patching vulnerabilities, closing that. So finding flaws. It's still the same goal, but you can do that differently in the cloud. So don't lift and shift. Think about, with your development teams, these are the ones that are really capable of thinking in a cloud way. How could we achieve the same goal in a cloud way? So if you have a control like, I don't know, I make a simple example, we want to have some kind of patching. Talk to the developers, how could we make sure? So translate that in a story. We want to make sure that our systems are not vulnerable. And then sit together with them and try to find out if they come up with a good solution, because technically they will be more advanced than you. They will be smarter than you if it's about cloud. So listen with which solutions they come up. Then you can take that, also talk to vendors and find a way how we can achieve, for example, vulnerability management in a modern way in the cloud. You want to achieve the same like in the past. The goals have never changed. The path to that goal has changed. It's like I always compare it with kids. So I have 2 kids, and so I don't beat my kids, actually. So that's a good thing, I think. No one should do that anymore. If you would have talked to parents 100 years ago, for them it would be normal if someone doesn't behave to beat them. But our paths achieving good behavior have changed, and this is just an example how we can do that differently today. So what is modern cloud, or general cloud and cloud security? So past security was very network driven. The network is still there, but the network is no longer that relevant. So modern security is data and identity driven. So you can use the data, do data analytics, and everything is an identity. If you look in an AWS environment, it's all about IAM roles. So if you look at attacks that happen in the cloud, most of them are like leaked credentials, leaked API keys, and from there on, misusage of these keys. So it's very identity driven what happens in the cloud. This is like the entry door that you need to take care of. Now this is a little bit more complex. What should you do in the cloud? The core idea of having DevSecOps, this is a blueprint for DevSecOps, I will just walk you through, is that you embed security in the product. The ultimate goal for me always was having, as a result, a resilient product, digital product, like e-commerce platform or whatever. So how do you achieve that? How do I enable everyone doing the same thing, the right thing? So it starts on the left side. Everyone is writing code. Shift left, everyone has heard that, but it means you want to fix things as early as possible on the left side. So infrastructure is code, and your product is code, like Java or JavaScript or something else. So both is code, and you want to find a way, I won't talk about zero trust, but find a secure way to commit that to your repository. As everything is code, the repository, either GitHub, GitLab, Bitbucket, wherever it is, but this is like an essential part. If your repository gets breached, I've seen that, you're done. That's the end of your life. You can really go home, because that's where everything is provisioned in an automated way. So think about how to secure that. From there on, if your code is in the repository, for example, your infrastructure code or your product code, you can do the automation. You don't have to run audits manually. You have like product code scanning, SAST scanning. You can check for secrets, misconfigurations, everything, and you can do the same for infrastructure code. And there are disciplines in between. Before anything is deployed, you can run all that. So if you find a flaw, so someone has an OpenS3 bucket, a misconfiguration, has public access to configured to anything, or has written like shitty code, well, you should find that here and fix that here. It should create like a feedback loop back to the developers in the language and the tools of the developers. So don't use it in the security tool. That's nice for us as a security people if we fix the code. If we don't fix the code, if the developers shall fix the code, give the feedback directly to the developers. They are the ones fixing the code. Developers are lazy. Is anybody a developer here? Very good. So I still make that statement. Good developers are lazy. So the best thing that could happen to you is you write product without even typing, code without even typing. So in the end, if you always make the same error, you will get the feedback back. And this is annoying. From any tool that gives you feedback, like pull requests or anything else, this is super annoying. So if you're a good developer, you will learn. That's how you learn. So you want to avoid that, because you are there to create features, not security. So you will learn and write better code. If you don't do that, maybe you're not just lazy. Maybe there are other skills that you have that I won't mention. So if you pass all the gates that you have, it ends up in production. In production, you can do so many things. In the past, we did a lot of DAST scanning, so pen testing, automated scanning for vulnerabilities. This is more or less that category. You can do different things now with cloud vulnerability management. And there is disciplines like CSPM and KIEM. CSPM is checking your runtime environment for the configuration, so that's posture management. KIEM is identity management and entitlement management. I always encourage everybody doing bug bounty programs. So I've started a couple of them. Bug bounty programs are very powerful, but you shouldn't start a bug bounty program if you don't do anything else of that. So if you think, let's start a bug bounty program, by the way, it's the best tip. Go to your developers and say, hey, I'm the new security guy. Let's start a bug bounty program immediately. They will tell you no. And they will tell you why. So you know, why is this our code is shit? Okay, let's do like SAST scanning, we need that. So it's a good way to trick people to come up with solutions. Then DDoS protection, a must-have, and it's on here. Only UEBA, that's user and entity behavior analytics, and CWPP that's like an agent on your cloud workload. These are the only ones that detect anything. All the other things on here, they are proactive. They find flaws that have not been exploited yet. So if you really want to detect, it's like if you have a kid, if you want to know if it's burning in the room of the baby, you need some kind of sensor there. Whatever anybody says, there is no way to detect an attack in another way. So if really someone is attacking you right now, it's only that reactive, detective technology that can help you. And keys to do all of that. So cloud security is that, CNAP mostly. That's the category where also we are in. And there you do like from infrastructure as code scanning to the agent up to CSPM, Cloud Vulnerability Management. That's a category defined by Gartner, surprise, but that's a category where we are in, and that's where also other vendors are in. So that's the cloud security part. Because you can do all of that, or you can look, I'll just pick a solution out in the market that can help me. So the magic is not that you do, for example, library checks or that you do CSPM. The magic happens if you can enrich the context to each other. I'll make a super short example due to the time. If you do vulnerability scanning, usually you get that also with DAS scanning, you find thousands of vulnerabilities, depending on your size. So let's say you do that with cloud vulnerability scanning, like registry scanning, you might find 1,000 vulnerabilities. But this doesn't help you. You want to know if they are actually being used. So if you have, for example, Chrome and Firefox on your computer, because your developer said Firefox is much better, but you never use it, you use Chrome. If the Firefox has a critical vulnerability, you can give a shit. You don't have to patch that. But if Chrome has a medium critical vulnerability, you have to fix that because you use that all the time. So you can, with the runtime information, you can get the context and find out if something is active, so if it's really being used. And then you can have all the feeds from somewhere. Is a patch available? Is that vulnerability being exploited out there? And then you can find out, for example, is that host where all the vulnerabilities that are active and exploitable, if they are there, if that host is reachable to the internet. If it is not, it's not that critical for you to fix that. But if it's reachable to the internet, if there are critical vulnerabilities that are active, then yeah, you should run and fix that. Without all that context, you just find 1,000 vulnerabilities and you don't know where to start. So that's where the magic of, let's say, CNAP starts, where all these different features talk to each other and enrich the context. And in the cloud, you can perfectly do that. So that's where the power of the cloud lies within. So to finish it up, don't lift and shift your workloads. Don't do that. Never. Even don't think about that. If someone tells you we could lift and shift, take aggressive measures against him or her. And don't lift and shift your security. It's the same. Think about that. You want to achieve the same goal, but do it differently. Do it in a cloud-native way. Do it in an engineering way and talk to your developers. CNAP is a good category where you get a lot of value out. And that's the real magic that really happens if all the features talk to each other. And the last one, I didn't talk about that much, but I mentioned it that you have the capability of scalability in the cloud. So you can use behavior-based analytics and move away from rules. We only had rules in the past because we didn't have the scalability. Now we have the way to do that, like we do now with ChatGPT. We have the capability in the cloud to do machine learning, so use that and do behavior-based analytics. That's much better than anything else. There are no numbers on the booths. So if you find our booth, just go down the stairs. But I did the presentation, of course, in advance, so if you find the number somewhere, that's also good. That's a good trick. We also have a cool Lego, but happy to continue the discussion with you. And I hope you enjoy lunch.